The impact of commercial real estate on the carbon footprint of the environment is huge. From the building of those buildings, from the construction of the materials that go into the buildings, the steel, the rebar, the cement that makes up the concrete, the transportation of those materials, and then the building of the building is about 30% of the entire carbon footprint that the building will have throughout its useful life. The other 70% coming from the actual operation of the building, the running the heating and cooling units, artificial lights, computers, that kind of thing in the building. And typically at the end of the useful life of this building, we're going to take that embodied energy and that entire carbon footprint and throw it into the landfill and start over again. But what if we were able to recycle and repurpose these buildings and do that in a way that was net zero energy, so the building generated all the power it was going to use by itself on site with renewable sources, carbon neutral, we cap off the gas lines, an all electric building. We do that in a way with a very strong emphasis on the health and wellness of the occupants in mind. So working under natural light, higher indoor air quality, connectivity to nature, better acoustics, better thermal comfort. And what if we were able to do all of that at a price point that was more profitable than the less expensive way of building to meet minimum code? Well, a developer building owner will tell you the perception is it's just too expensive. And I don't believe it's ever going to resonate in the private sector unless we can prove it can be done more profitably than the less expensive way of building to meet minimum code. So let's take a look at a new design approach that might be able to get us here, and that's a holistic, integrative design approach. And what does that mean, holistic? It means everything together. So instead of saying and looking at something in isolation like a solar array and saying, I'm going to spend $100,000 on a solar array and it's going to reduce my power bill $20,000 a year. And based on a 5-year payback, I'll either do that or I won't. And we make that decision on LED lighting like that and on HVAC tune-up, all in isolation of themselves and of each other. As opposed to a holistic approach would say we're going to use every building method and material to serve multiple purposes, and we're going to use technology along with these methods and materials to maximize what nature gives us for free. And then we're going to have health and wellness in the backdrop of all of this and weave all that together into a fabric of sustainability that's cost effective, where the sum of the parts is greater than the whole. And we'll talk about what some of these holistic approaches are in a few minutes. The integrative design part of it, what does that mean? Well, in a conventional design approach, I would look at a building and I'd say, okay, I want to renovate that. I'd pull in my architect and we'd sit down and say what the exterior should look like and how those upgrades should be and how many offices, how many conference rooms and how many break rooms and that kind of thing. And he would lay all that out so it met code. And then we would send those plans out to all of the engineers and interested parties in isolation of each other. And so the electrical engineer would come back with a lighting plan that was appropriate, and the mechanical engineer would design a heating and cooling plan that was appropriate for that space and to heat and cool it properly, and the structural engineer would do his thing, and on it would go. And then we'd assemble those plans, send them off to the city for permits, send them off for the contractor to get pricing, and that's how it's done. In an integrative approach, we had all those parties at the table at the same time. And so the contractor, the architect, myself, the building owner, the electrical engineer, the mechanical engineer, the solar engineer, the battery engineer, the property manager that's going to live with the operations of this project, the marketing team that's going to market this and try to get rent and lease it, would all be there. And the way a conversation might go in an integrative design approach would be, here's a building that we're going to renovate that was an old racquetball court that had absolutely no glass. It had 2 storefront windows in the front doors, and that was it. No glass on the other 4 sides of the building. And we wanted to punch a lot of holes in the building. So I would hand the plan to the architect and say, what do you want, floor to ceiling glass? I would look to the structural engineer and say, could you get out your red pencil and draw a line around the area that we can punch out holes in the windows and for the windows without structurally impairing the building too much? He would do that, and then floor to ceiling glass, and the mechanical engineer might say, well, the insulation value of glass as opposed to insulated concrete is much lower. So we're going to have more heat gain, which means I'm going to need bigger mechanical equipment that's going to be on more often. And that means more power. And then how much more power? And he'd tell us, and then the solar engineer would say that's a solar array that's X amount bigger. And on it we'd go, and we'd have this roundabout conversation while the contractor is giving us real-time feedback until we came to that place where the vectors of efficacy cross to make the best economic decision for that building and for that particular methodology of punching in glass windows. And we do that with every method and material in the building. We wouldn't be able to do that anywhere near as cost effectively if all of those entities were in isolation of each other, and all of their opinions are equally important. It's very important to realize that. So the marketing team, they're trying to get me the highest rent they can. So what the market wants is important. The engineers are trying to reduce my power loads and reduce my operating expenses as much as possible, as well as first costs. And so what they have to say is important. And the contractor's trying to drive my first cost down as much as he can, and that's important as well. So everybody at the table is on equal footing and is equally important. And that's what an integrative design approach looks like. So when we're talking about holistic, we're talking about one product serving multiple purposes. What does that look like? Well, here's a building where we insulated the outside of the walls and we left that concrete exposed because that thermal mass is a very efficient heat sink and will act as our air conditioner. And we had insulation, bad insulation. It's not very attractive, insulating the underside of the ceiling. And we wanted to cover that so it would look a little more elegant. But because of all the hard surfaces we had exposed on the walls and on the floor, I wanted something that would absorb sound, give a better acoustical experience. And so we found a panel fabric made for movie theaters that had reflective capabilities. And we used that and pushed it as high as we could within the beautiful wood structural system of the building to hide that insulation. So now I've got one product that's hiding the insulation, absorbing the ambient sound in the building, has reflective capabilities, so it's spreading my uplights evenly across the space in a very elegant fashion. It's exposing the beautiful wood structural system. And at the same time, we installed it for about 80% of the cost of a typical office ceiling. One product serving multiple purposes. What does it look like to try to use methods and materials and technology to maximize what nature gives you for free? Well, this is that same building, and the picture on the left is this building with no lights on before the renovation. We then developed a skylight where the angle of the aperture, the orientation of the skylight, the shape of the shell, everything was exactly where those vectors of efficacy crossed to maximize the harvesting of daylight while minimizing thermal gain. Very, very efficient. And the picture on the right is this picture of that same space, same time of day, after the renovation with no lights on. All of that light is 100% for free for the life of the project, using a building methodology and some technology to maximize what nature is going to give us for free. And so that gives us a little bit of a feel for how we can use this holistic integrative design approach to gain greater value. So what does that mean economically? Well, we hard bid this project as though we built it to meet minimum code. And we compared that to what we actually spent to obtain our original design objectives, which again were net zero energy, carbon neutral with a strong emphasis on health and wellness. We now have natural light, connectivity to nature, better, higher indoor air quality, all those dynamics. And we spent $50 a square foot more to build it in this way than we would have had we built it to meet minimum code. But at the same time, because we were so differentiated from the rest of the product in the marketplace, the product leased more quickly than anything else was leasing on average, got higher rents than the highest rent ever asked for in the marketplace, and we drove our operating expenses down significantly by eliminating we have no gas bill, we don't even have a gas line, and eliminated our electric bill, and we reduced our water bills, and we reduced our maintenance and our reserve requirements. And after all of that, had I sold that building the day after it was completed and occupied, we would have recovered that $50 a square foot and made an additional $100 a square foot of profit. That's pretty solid economics. So we've talked about the whole holistic design approach, and we've always had this health and wellness piece in the background, but what does that mean economically, and who benefits from it? So economically, we went to a group out a consulting firm in San Francisco that took over 60 very robust studies on health and wellness and how healthy environments affect people's cognitive retention, productivity, how it affects their health, their wellness. They did studies on people in work environments and whether they, how much they would rather work in that environment versus go work in an unhealthy environment or an environment that was built and was resonant with meeting minimum code. And when they compiled all that, they were actually able to take very conservative assumptions and quantify the value of the health and wellness to the company that occupies that building. And what they found was the increase in productivity was so high, and the tenants were so happy in that building, and the occupants were very reticent to leave that to go to another place. And so their recidivism rate was high, and their turnover was low, and they had fewer sick days. And when they applied all of that economically, they found that a typical tech company's productivity and profitability went up 6.29%. So with a typical 150,000 square foot tech company at 5.5 people per 1,000 square feet, generating $540,000 a year of revenue, which is average for a tech company, and an average salary of $100,000 per employee, that meant $2,870,000 of increased profit to the bottom line per year. That's a pretty strong number. So when we look at this in conjunction with what we've done on the building side, where we picked up $100 a square foot in value, that's 100 on a 150,000 square foot building. That's a $15 million increase in value after we've recovered that $50 a square foot. On the tenant side and the occupant side, the numbers are even greater. As you can see, that $2,780,000 of profit ended up at a 15 times price earnings multiple, which is typical for a tech company. That's $41.7 million of additional value to the tenant. These numbers are absolutely staggering. $56 million of increased value after recovering your initial investment. So what does that mean to buildings as a whole, and how we approach these existing buildings and all of this existing building stock? Well, that building I talked about earlier, the racquetball court that we wanted to renovate, we actually analyzed that as though it were a conventional renovation. And the economics and the numbers clearly said you scrape that building, throw it into the landfill, start from the ground up and build a new building. But when we were able to drag this $100 a square foot of additional profitability along and plug that into the equation, it flipped the entire analysis. And now it made more economic sense to keep that building, renovate it in this manner, and get that additional value. So that's a very important dynamic for existing buildings, because we're now keeping all of that existing building stock out of the landfill, and it makes economic sense to do that. So what are the takeaways from all of this? Well, as a building owner, significantly more profitable than had we built to meet minimum code. We've already proven that. As an occupant, who's getting the benefit of all this health and wellness? Well, it looks like it's all the occupant, right? Well, now my occupant, my tenant, is financially stronger by $41.7 million. So a stronger credit strength, more profitable. I have less risk that I'm going to lose that tenant to either bankruptcy or not have the ability to pay my rent. Lower risk, and because I have a stronger credit, that increases the lower risk, increases the building value. Increase in building value means that my loan is got stronger collateral. Stronger collateral on the loan means I'm probably going to get higher loan to values and lower interest rates. And you can begin to see this domino effect of benefit and profitability that all three of these parties are having. The occupant, the building owner, the lender. The occupant has also now got these buildings that they're fighting for talent out here, and that's a very important piece of the economics of this. So when you've got Apple and Google and Amazon and Facebook and all of these tech companies trying to get the best engineering talent there is, having a healthy environment where they're going to want to work more versus an unhealthy environment that was built to meet minimum code is becoming very, very important. So they're starting to have this cumulative effect of economics on this that absolutely make no sense whatsoever to go the other direction. And so the one entity that we've not brought up yet that is integrally involved in all of this is the earth and the environment. We've taken the embodied energy of this building and not thrown it into the landfill. We've repurposed it. We've taken our operational carbon footprint and basically made it zero. So we're operating in this building now with no impact on the environment. And that's the big winner. And so we started this conversation with what if we could do all these things? And I'll kind of end this with another question of, knowing what we know now, why in the world would we ever design and build any other way again?